Hello guys, and we're now on topic 3, part 3 for money time relationship, and which is part 3 is ordinary annuity. So recall part 1 is simple interest, part 2 is compound interest, and this one part 3 is ordinary annuity. Now, what is annuity? Annuity is a series of equal payments occurring at equal periods of time. So, with respect to the cash flow diagram, this here is the cash flow diagram wherein you have at the start, then after first year, you have A, where A is the uniform periodic amount. So, meaning this is an amount whether it's a payment or a deposit. Basta it's a uniform amount and is also periodic, meaning it will occur at equal distances or at equal lengths of time. For example, this one, let's say in the first period you have an amount A, then in the second period you have an amount A, third period amount A, and so on and so forth. Now, let's say this is a payment. So, for example, this is a borrowed amount. So, for annuity, on the first interest period, there is a payment A. The second period, there is a payment A. Third period, there is a payment A. So, for this one, annuity is basically just equal payments occurring or equal deposits occurring at equal periods of time. So, sa Bisaya pa, mura ni siya kanang kung naa kay gibayran ay kung naa kay hiram, na kay utang, imong gihinahinayan og bayad at the same exact amount at the same exact time. So, sample, every year na ginahinay kag bayad or every month na ginahinay ka og bayad og the same nga amount. So, that is annuity. Now, there are four general types of annuity. So, first, mo ni ang part 3 kaning ordinary annuity. Then you have deferred annuity, annuity due, and perpetuity. For this part 3, I'm only going to discuss ordinary annuity. Okay, ordinary annuity. What is ordinary annuity? Payments are made at the end of each period. So, every period, ang katapusan ana, there will be a payment. Sample, this one. Let's say, this is at the start, then the beginning of the first period, then the end of the first period. So, at the end of the first period, you have the payment A. Then, if this is the end of the first period, subsequently, this is also the beginning of the second period. And then you have here the end of the second period. So, at the end of the second period, you have the payment A. And so on and so forth now for the end of the third period, payment A. End of the fourth period, payment A. And so on and so forth. So, for example, let's say every period is monthly or let's say every period is annually. So, at the end of every month, you're going to pay. Or at the end of every year, you're going to pay. So that is ordinary annuity. Every end of each period. Now, how to get how to determine the future amount or the present amount of ordinary annuity? So you have here the direct formula. I'm not going to derive na anymore because it will take time. So here, if you want to get the future amount, okay, the future amount of your periodic payments, so you have here the formula A times 1 plus I to the power of n minus 1 all over I. Or if you want to get the equivalent present amount of all your payments A, then you have the formula A times 1 plus I to the power of n minus 1 all over I times 1 plus I to the power of n. Now, as you can see, medyo complicated na. So again, ang kaning engineering economy, more on formula gid ni siya. So the more we proceed with our topics, the more magakomplicate ang atoang formula. But here, don't worry, is because naan is like parehas ni sila gamay. So as you can see, ang numerator diri parehas ra na sila. 1 plus I to the power of n minus 1. There is 1 plus I to the power of n minus 1. Kalahian lang yun sa future amount, ang denominator I only. Sa present amount, instead of I, naapay na po nga 1 plus I to the power of n. Okay? So, basically, this is the formula for the future amount and the present amount. But take note, you can also use katong formula sa compound interest, which is F equals P P times 1 plus I to the power of n. Okay? Because what if, for example, what if makuha nimo ang present amount, okay, using this formula? Yeah, what if kailangan po ng future amount? So, kung kailangan po ng future amount, no need na nga mo gamit ka ani. For example, if naanak ka ani, makuha na nimo ng present amount, you can directly use the compound interest formula nga F equals P times 1 plus I to the power of N. Okay. And also, katong ko ano, tong types of interest sa compound interest, still it's still usable here wherein I is equal to R over M and N is equal to M times T. So kung imo ni siyang i-apply no sa formula sa future amount ug sa present amount, kaning I dere again these are R over M. Okay, kani pong I R over M, nya kaning N dere M times T. Okay? So compounded na gapon ang interest ani, pero nakalahi lang yun is naalang kay maginahinay lang kag bayad. Okay? Naalang kay equal amounts of payment at equal periods of time. So may nakalahi ani sa compound interest. Ang compound interest is one time big time ang payment. Example, ni borrow ka at the start. Okay? Then after let's say on the fourth year bayaran nimo. So kana ra mo ray may tabo. Wala ni silang mga multiple payments. Pero sa annuity, hinahinayan nimo og bayad. Mura ni siya og kanang ang term pa sa kanang mga ko ano, mga kumalit ka og balay, kumalit ka og auto. Okay? So pila mo na ni siya ang kanang kay in a way no, in a way mura na ni siya og mura na ni siya mauna ni siya ang gitawag na to og installment. Okay? So sa compound interest bayad ka diretso. Pero sa ordinary annuity mura ni siya ganang installment nga at every set of period of time, let's say every month maginahinay kag bayad hangtod ma hurot nimo og bayad tanan nimong borrowed amount. Okay? So mura na ni siya og kanang installment. Okay, now how about let's proceed to applying examples for ordinary. Example number 1. Mr. Bean wishes to deposit 10,000 pesos per year to his savings account so that he can afford to buy the things he wants in the future. So if the account has an interest of 7.5% compounded annually, how much will be the accumulated amount after 20 years? So for the solution, okay, for this example you are given, so here the 10,000 pesos, that is a deposit that will be made per year. So technically that is A. That is our annual, that is our periodic amount of payment A. Kanang 10,000 pesos. And then take note that the account has an interest of 7.5%. So that is the rate of interest, 7.5%, but is compounded annually, so at M equals 1. Okay, at M equals 1. And the question is, how much will be the accumulated amount after 20 years? So it's very obvious that the time here is 20 years. Okay? And the question is, you need to find the future amount. Why the future amount? Because from the problem itself, how much will be the accumulated amount after 20 years? So from the word after, meaning in the future. Okay? So that's why we need to find the future amount for this problem. Now, in this problem, everything is already given. So, we'll just have to substitute directly everything in the formula. So, remember the formula, F is equal to A times 1 plus I to the power of M times T minus 1 over I. So, A is 10,000 pesos. Then 1 plus, again, I is equal to R over M. So, that is 0.075 for 7.5% divided by 1 for annually. To the power of M times T, so 1 times 20, minus 1 over 0.075 divided by 1. So, for this one, the answer is 433,046 pesos. Let's proceed to example number 2. Okay, example number 2. An individual contributes 200 pesos per month to a retirement account. The account earns interest at 8% compounded monthly. What is the value of the account after 35 years? So, if you're going to look at the solution, you're also given the periodic amount of payment A, which is 200 pesos. So, this is made per month. So, this will be your periodic amount A. Then, the interest here is 8% compounded monthly. So, the rate is 0.08 at M equals 12 because it is compounded monthly. And, you're given here after 35 years. So, time is 35 years. Now, you need to determine the future amount. Future amount because, again, the word after. So, we need to determine the future amount. So, same with example number 1. Example number 2 also has everything given. So we can just directly substitute. So here you have the future amount equals A times 1 plus I. So I is R over M. You have 0.08 over 12 to the power of M times T. So 12 times 35 years. Minus 1 all over I, which is R over M. That is 0.08 over 12. So after 35 years, you will have a future amount of 458 peso, 458,776.5 pesos. Okay, let's proceed to example number 3. Okay, example number 3. A man is considering the purchase of a used automobile. The total price is $60,200 with $10,240 as a down payment and the balance paid in 48 equal monthly payments with interest at 2% compounded semi-annually. Compute the monthly payment. Okay, the payments are due at the end of each month. So here, it's being stated that the payments are due at the end of each month. So it's just telling you that this type of problem is an ordinary annuity because the payments are made at the end of each month. Okay? So solution. So let's list down first the given. So first you have the price, the total price of the automobile, which is $60,200. Now recall, as I've said, price is just equal to the present amount. Okay? So your price is the present amount P, which is $60,200. And you also have a down payment. So let's assume I'm just going to assign it with DP as down payment. The down payment is $10,240. And you have the rate, which is 2% at compounded semi-annually. So M equals 2. Then you have here N. N equals 48 interest periods. Why did I directly put here N? Because in the problem, it is stated here that and the balance paid in 48 equal monthly payments. So meaning, the problem specifically states here that this purchase of the automobile, the remaining balance, will be paid all throughout the 48 months. So meaning, this is the total interest period, 48 months. So meaning, that is your N already. Or if you're going to use M times T, you can just determine how many years is 48 monthly payments. So to determine the year, 48 months divided by 12 months in a year. So if you're going to use M times T, you can have T is equal to 4 years. Now, question is the payments. Question is compute the monthly payment. So monthly payment, meaning we need to determine the periodic amount at a periodic time. So meaning we're going to determine A, the periodic amount needed at a specific periodic time. So for this one, we need to find A. Okay. Now, how to solve for this one? Now, you can directly assume N because the problem specifically stated that the total payment will be 48 months. Okay, so that's what I've said in the previous slide. Or you can also use a general N equals M times T formula. So that's why if you're not aware with 48 months being N, you can just directly use the M times T. Okay, so that you won't have a problem with determining N. So 48 months, again, that is 4 years. Now also, remember that down payment is made at the start of the transaction. So you can assume that it is a present amount. So every time you're going to make a down payment, of course, it's always at the start. Okay, where can you see a down payment? It's made after 10 years. So when you say down payment, it's made on that moment, on that present moment. So meaning down payment, you can call it as a present amount also. Now, down payment is a part of the price. So the total price of the car is equal to the down payment plus the present worth equivalent of the monthly payment. So meaning, kanang total price sa car nga $60,200, that comprises of kung pila tong present amount sa tanang monthly payment plus ang down payment. Always yun ang inana. Apart na gid na perminti ang down payment sa imuhang total price. Okay? Now, next. Okay, another one. This is also very important. Okay, this is very important for annuity. Okay, another very important thing to take note is the difference in payment and interest. Okay? Take note yun ni basa annuity. Okay? Now, payment is done monthly. So remember, for this problem, you have to pay 48 equal payments in 48 months. While interest is semi-annually. So remember, the interest here for this problem is 2% compounded semi-annually. Now, very important, for annuity, kani, importante jud kay ni gyud. Okay? For annuity, payment and interest must have the same time period. Now, this is very important. Okay? In all types of annuity, okay, in all types of annuity, this should be the same always. Payment and interest must have the same time period. Meaning, kung payment nimo monthly, imong interest dapat monthly sad. Or, kung yung payment nimo is yearly, dapat ang imong interest yearly pud. So, basta annuity, it should always be the same ang payment o ang interest. Now, for problems regarding annuity, usually, ang given nga payment, ang payment ihatag na gina diretso. Okay? So, example, payment nimo is monthly or payment nimo is annually. Nya in actual scenarios, lisod na nausbon ang time period sa payment. Okay? So, lisod na usbon, for example, nakaset na nga monthly. So, lisod na usbon, kung mo pa nang usbon into yearly or mo pa nang usbon into quarterly. Lisod na. So, para sa scenario sa annuity nga dapat parehas ang payment ug ang interest, okay? Ang only way na lang yun is only the interest will have to be converted in favor of the payment. So this is the only way nga mas dali mas dali nimo masunod ang rule sa annuity nga dapat payment and interest must have the same time period. So pwede nimo i-convert ang imuhang rate, okay, ang imuhang interest rate. So in this case, since payment is made monthly, then interest should be converted to compounded monthly. For this one, mag-convert ka. But recall sa atong discussion sa compound interest, pwede kini siya ma-achieve. So again, this can be achieved using the previous method from the compound interest, which is ERI. So recall mo atong ERI nga kung gistorya, pwede ka nimo ma-convert ang usa ka type sa compounding into another type of compounding. So mo ni siya dako jud kay gamit sa ERI for. Okay, so for this problem, what we're going to do first is we have to convert first the interest rate because we cannot use the interest rate that is not of the same time period with your payment. So first, converting first the interest rate from compounded semi-annually to compounded monthly. So we can, again, from the previous discussion sa compound interest, we just have to, for conversion, they must have the same ERI. So, for this one, i-equate ra nimo ang ERI sa compounded semi-annually to the compounding nga gusto nimong mausab. Okay, so for this one, which is compounded monthly. So, with your formula, 1 plus r over m to the power of m minus 1 equals 1 plus r over m to the power of m minus 1. So, of course, this side is the compounded semi-annually, and this side is the compounded monthly. So, you have here, for this side, for the compounded semi-annually, which is 0.02 over 2 to the power of 2. And for this side, which is for the compounded monthly, r, you need to find out r. For the compounded monthly, you have 12 to the power of 12. So therefore, using your calculator, r is equal to 0.01992. Meaning, this will be now our new interest rate, which is 1.992% compounded monthly. So, with this converted rate, this will be your new rate nga imuhang gamiton para pag-solve sa imuhang problem. Again, dili ka pwede mo proceed sa pag-solve sa imuhang problem kung ang imuhang interest rate wala pa nimo mapareha sa imuhang payment. It should always be your interest rate should be of the same time period to your payment before you continue with the solution. Okay, now let's continue with the solution now that we have our new interest rate. Now, then, we can proceed directly to solving the monthly payment using the formula for present amount since the price is given. Okay? So, we're going to use the formula for present amount because, take note, remember nga, kitagaan ta diritso og price sa automobile. So, recall ka, ang price sa automobile ato is $60,200. Nya, what we need is the payment A. The periodic amount A at every month nga payment. So, what we need is this one. So, since na naman tayo given nga P, kanya itong gamiton nga formula. Ano mangita man, ano mo gamit man ta sa F sa formula sa future kung naa naman day kay given nga present amount. Okay? But remember that down payment is part of the price. So, imuha ding price di ay is basically ang down payment plus ang katong pilay total sa imuhang monthly payment. So with this, everything is given already. The price is $60,200. Recall that the down payment is $10,240. Then plus A, we needed A. Then 1 plus I, again, I is equal to R over M. That is 0.01992, the new rate, which is now compounded monthly, divided by 12 to the power of N. So M times T, you have 12 times 4. Minus 1 all over I, which is 0.01992 over 12 times 1 plus 0.01992 over 12. Again, this is still I to the power of N or M times T. 12 times 4. Okay? Then, using your calculator, you can directly use shift. So, answer is $1,083.72. Meaning, for this automobile, the monthly payment after considering the down payment of $10,240, you will have a monthly payment of $1,083.72.